Hello, sir. My name is Tiffany. I am a 12th grade student from SMA Mary Joseph, and today I will be talking about the topic ideal gases. So first, we have the first formula, which is Boyle's law. It is P1 times V1 equals to P2 times V2. P1 is the initial pressure, and V1 is the initial volume, and P2 is the final pressure, and V2 is the final volume. So here, if we know 3 of the 4, we can calculate the fourth. So this is the first example. Question number 1. A fixed amount of a gas occupies a volume of 1 liter and exerts a pressure of 400 kilopascal on the walls of its container. What would be the pressure exerted by the gas if it is completely transferred into a new container having a volume of 3 liters, assuming the temperature and quantity of gas remains constant? So here we are given the initial volume, which is 1 liter, initial pressure, which is 400, and the final volume, which is 3 liters. And here we are asked to find like the final pressure. So we just have to insert the numbers to the formula and then cross multiply. So we get P2 equals 133 kilopascals. This is the second example, question number 2. A sample of oxygen gas has a volume of 150 milliliters when its pressure is 0.947 atm. What will the volume of the gas be at the pressure of 0.987 atm if the temperature does not change? So here we know the initial volume, the initial pressure, and the final pressure. We just have to do the same. We insert the known, we insert what is known into the formula, and then we cross multiply. So here we get V2 equals 144 milliliters. This is the third question for people to try for themselves. And then there's the second formula. So here, T means temperature of the gas and V means volume of the gas. So in Charles' law, the pressure must be constant. So question number 1, calculate the decrease in temperature in Celsius when 2 liters at 21 Celsius is compressed to 1 liter. So here it is given that the initial volume is 2 liters and there's initial temperature. So here we have to convert Celsius to Kelvin. So we just have to add like 273 to the equation. Here we get 294. So the final volume is 1 liter. So here we have to find the final temperature. We do the same like before. We insert what's known into the formula and then we cross multiply and get that the final temperature is 147 Kelvin. This is question number 2. What will be the volume of a gas sample at 355 K if its volume at 273 K is 8.57 L? So here it is given that the initial volume is 8.57 liters and the initial temperature is 273 K and the final temperature is 355 K. Here we have to find the final volume. We do the same as before, cross multiply, and then we get that the final volume is 11.1 liter. This is the third question, which people can try for themselves. And then there's the third formula, which is Gay-Lussac's law, where P1 is the initial pressure and P2 is the new pressure. T1 is the initial temperature and T2 is the new temperature. So here's the first example. Question number 1. A sample of hydrogen at 47 Celsius exerts a pressure of 0.329 atm. The gas is heated to 77 Celsius at constant volume. What will its new pressure be? So here it is given that the initial temperature is 47 Celsius, which if we convert to Kelvin, it is 322 Kelvin. Oh, wait, it's 320 Kelvin. And the initial pressure is 0.329 atm. The final temperature is 350 Kelvin. So here we are asked to find the final pressure. We do the same as before, cross multiply, and then we get that the final pressure is 0.360 atm. This is the second example, question number 2. A gas is heated from 19 Celsius to 80 Celsius while the volume is kept constant. If the initial pressure was 2000 pascals, what is the pressure of the gas after it has been heated? Give your answer to 3 significant figure. So here it is given that the initial temperature is 19 Celsius, which is 292 Kelvin. Initial pressure is 2000 pascals. The final temperature is 353 Kelvin. So here we are asked to find the final pressure. We do the same as before. If we cross multiply, we get that the final pressure is 2420 pascals. Here is the third question, which people can try for themselves too. So that's it. Thank you for watching.